My name is A. Anil Kumar. I am an assistant professor working in Marri Laxman Reddy, Institute of Technology and Management, Dundigal, Hyderabad. Today topic is satellite communications. I am going to give introduction on satellite communications. These are course outline and we're having the course objectives, course outcomes as well as course syllabus. This is R22 regulation in our MLRS. We're having the 5 units in our satellite communications. First one is introduction, unit 1, that is unit 1. Unit 2 is satellite subsystems, and going to third unit, that is satellite link design, as well as fourth unit, earth station technology, and coming to unit 5 is deep space communications. These are the course objectives. We're having course objectives are acquire the basic knowledge of satellite communications principles. With this course, with this satellite communication, we are come to know about the principles of communications, satellite communications, and overview of types of orbits and satellites for the satellite communication, and overview of the how many types of orbits and satellites for the satellite communications we are going to discuss in this satellite communications. Like that, basic knowledge of link design of a satellite and multiple access systems, and understand the basic concept of earth station technology and their various types, gain knowledge on various machines like MOM, Chandrayaan, other missions. We're having in satellite communications, PSLV and Chandrayaan, we already known about that, but we are going to discuss in briefly in this satellite communication subject. These are the course outcomes. First one is understand the historical background, basic concept and frequency allocations for satellite communications. In this CO, we are going to discuss what is the history of the satellite communication from where to where. When the first satellite will be initialized or installed or introduced, we are coming to know in this unit, or else by using this CO and the basic concept of frequency allocations. We are having the different types of frequency allocations, that is LEO, MEO, GEO, like that. By using this CO, we are going to discuss about the frequency allocations for different satellite communications. Coming to CO2, demonstrate orbital mechanics, launch vehicles and launches. In this, we are going to discuss how the orbital mechanics will be there, how the launch vehicles will be launched from Earth, and how the launch vehicles will be taking out the satellites from Earth to the space. We are going to discuss in this CO, as well as design satellite links for specified CN with system design examples. We are going to discuss in this CO, design the satellite links. Visualize various earth station technology and their various types. In this CO4, we are discussing visualize various earth stations. How many earth station technologies are there and what are the types we are going to discuss by using this CO. And coming to CO5, understand the deep space communications. How the orbitals will be there, how the space and earth stations will be there, how the vehicles and these trajectories are there from taking the earth to space, launch vehicles and launch pads. We will going to discuss in this CO5. We are having the 5 units in this satellite communications. First one is introduction, that is origin of satellite communications and basic concept of satellite communication. What is the origin for the satellite communication? And after that, basic concepts, how the satellite will be launched from earlier days, and what are the types we are discussing in by using these basic concepts of satellite communications. Frequency allocations for satellite services. what are the frequencies are there, what are the types we're uh, going to discuss, and what are the applications. By using these satellite communications, where we are using, what are the applications we are going to discuss here. Orbital mechanics and launchers. Types of orbits and types of satellites. What are the types are there, and what are orbit types, and what are the types of satellites are there, we are going to discuss by using these types of satellites and types of orbits. Look angle determination, orbital perturbation, orbit determination, launches and launch vehicles, reusable launch vehicles, orbital effects in communication system performance. By using in this unit 1, we are going to discuss look angle determination, orbital perturbation, orbit determination, launches and launch vehicles. How the launch will be there, and how the launch vehicles taking out the our satellite from Earth station to the space, and effects in communication system we are going to discuss in introduction part. After that, unit 2, that is satellite systems. In these satellite systems, attitude and orbit control systems, telemetry, tracking and command and monitoring, power systems, communication subsystems, satellite antennas, equipment reliability and space qualification. In the satellite system, what we are having? Telemetry, tracking, how the satellite will be moving from Earth to the space, trajectory, and commands. What are the commands we are giving to the satellite from Earth station? How that will be going? How that will be moving from Earth to space? We are monitoring by using the command and monitoring. Communication subsystems. What are the any drawbacks will be there? We have to communicate with the satellite by using this technique. Satellite antennas, equipment reliability and space qualification. Going to third unit, that is satellite link design. In satellite link design, basic transmission theory, system noise temperature and GT ratio, design of downlinks and uplinks, design of satellite links for specified CN, multiple access, frequency division multiple access, that is FDMA, and intermodulation, calculation of CN, time division multiple access, that is TDMA, frame structure. Examples: satellite switched TDMA, onboarding processing, DMA, code division multiple access, that is CDMA, spectrum transmission and reception. We are going to study in this unit 3, that is satellite link design. And in fourth unit, Earth station technology. What are the technology we are having in the Earth stations? First of all, we are having two stations, that is Earth station and space station, where Earth station also called as ground station also. In this introduction, types of Earth stations, applications and its limitations, transmitters, receivers, antennas, tracking systems, terrestrial interface, primary power test methods, high power amplifier, that is HPA transmitter, and LNA receiver, very small aperture terminal VSAT and its applications were studied in unit 4, that is Earth station technology. Unit 5, final unit is unit 5, that is deep space communications. In this deep space communication, we are having the topics MOM missions, Chandrayaan missions and other missions, satellite navigation and global position system, that is GPS, radio and satellite navigation, GPS position location principles, GPS receivers and codes, satellite signal acquisition, GPS navigation message and GPS signal levels, GPS receiver operation and GPS CA code accuracy, differential GPS, latest trends in by using the satellite communications. We are already known basic on the satellite communications. what are the Chandrayaan, PSLV, PSLV-1? We are going to launch from Earth station, where all these things are going to discuss in these deep space communications and satellite navigation. How the satellite will be moving from Earth to the space, and how the that navigation will be there. That will be as route map also, and that is GPS, Global Positioning System. And these are the textbooks, and these are the references. We are going to take the notes or else any topics from the satellite communications. This is a basic introduction to the satellite communications. Satellite communications is a system that transmits information such as voice, video, or data. These transmission between two or more points on Earth by using satellite orbiting in space to act as a relay station. First of all, communication is nothing but the transferring the data or information exchange. In this satellite communication, the data will be the signal, how the signal will be moving from Earth to the satellite and satellite to the ground station, various resources. That is satellite communication. The data will be in the form of such as voice or else video or else data between the two or more points on Earth. The satellite receives signals from an Earth station and then transmits them to another Earth station. The satellite receives a signal from the Earth station. Earth station so that transmits the data for the satellite, and that amplifies the data, and required data will be given to the Earth station, that will be two or more points or two or more Earth stations, allowing for long distance point to multi-point communication over thousands of kilometers. This signal will be transferring over thousands of kilometers from Earth to space and space to Earth. This technology overcomes the limitations of line of sight communication, providing global coverage for services like GPS, broadcasting, and internet access. This basically the satellite communication will be used for the GPS services, that is global position systems, and broadcasting. Broadcasting means the multimedia or internet access. For web browsing, we are using these satellite communications, and we are having these. We are seeing here. This is a satellite, and this is uplink, and this is downlink. This is a ground station. This is a ground station. This is a ground station. We're having the here satellite. This satellite will be taken the signal from the inputs from the Earth, and this is the also Earth. This is the ground station. This is uplink and this is downlink. After reaching the data to the satellite from the Earth, and that will be giving to the another Earth station, two or more Earth stations, by using this downlink. This is uplink and this downlink. These are all the small descriptive part for the satellite communication systems, and after that we will discuss some more topics. Thank you.